Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 267, I chat with Ray Kimber about cables and his isomike. So stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Home Theater Geeks is provided by CacheFly at CacheFly.com.
This is Home Theater Geeks with Scott Wilkinson, recorded August 6, 2015. Episode 267, Ray Kimber on cables. This episode of Home Theater Geeks is brought to you by Casper, an online retailer of premium mattresses for a fraction of the price. Because everyone deserves a great night's sleep. Get $50 off any mattress purchase by visiting casper.com/HTG and enter the promo code HTG. And by the new Epson Workforce printers powered by Precision Core. Workforce is an award-winning line of all-in-one printers for your home office, small to large business, or corporate work groups. Visit Epson.com to find out more. Hey there, Scott Wilkinson here, the Home Theater Geek and editor of avsforum.com. This week's guest geek is Ray Kimber, founder of Kimber Cable and a long-time and well-respected member of the audio industry. Hey, Ray, welcome to the show.
Well, hello, and thank you for having me.
So glad that you're here, and thanks for being here. Those of you who are tuned in live at live.twit.tv or logged into the chat room at irc.twit.tv can post questions for Ray as we go, and I'll pass along as many as I can. So, Ray, let's start with a little bit of history. How was it that you got interested in audio and particularly cables?
I had always been the kid that had his room wired. My father was an electronics technician, and so I had early exposure to meters and oscilloscopes and vacuum tubes and all of that, and ended up working for a large company in Los Angeles when I was there. And this was right when the disco craze was first starting. And we had a problem because the sound systems were much higher gain than typically would be expected. And unlike in a normal theater, where the speakers are on the proscenium and the lights are on stage and from the back of the hall, the lights were hanging with the speakers. And we had a tremendous noise problem.
Oh, man.
Putting the cables in conduit cured one problem and then had another problem because with the power levels were high enough that it would actually rattle the conductors inside the conduit with the inductive force. And so I thought back to my days of Boy Scout, boondoggling, Eagle Scout here, and I thought, well, if we counter-rotate the wires, wouldn't it work? And so I braided a section of 10 or so feet by hand. It looked a little ugly, but it worked. But much to my astonishment, it sounded more pure on top of the lower noise, and so that kind of started the whole effort towards figuring out what was going on and how to exploit these advantages. So it started from a need.
It started from a need, as so many things do.
Yes.
Now, when you braided these cables, sort of combined them together, you got lower noise. Do you think that resulted in a perception of better sound, or was there something on top of simply lower noise?
Well, there was definitely something else going on there because it sounded more precise, I guess, for want of a better word. There was less intra-note noise. And when we really took a look and was pulsing audio down the standard cables, they would ring at frequencies and figured out that ringing was in turn kind of goofing with both the negative feedback loop and the current limiting circuits. The amplifier was viewing it as low-level oscillation, which of course it would want to clamp down on. And then since the ringing appeared at the output terminals and wasn't on the input, the negative feedback loop wanted to correct it, which adds its own little problems of additional distortion. So, and then of course, lower series induction is always good for power. It just simply keeps the voltage and the current in phase with each other.
So that led to thinking about how can I make better cables?
Yes. So we sold quite a bit. One of the problems was that trying to have someone braid it was really a problem, because braiders want to braid something that is both flexible and limp. Wire is flexible, but it's not limp. So we had to have our own braiders designed for us. The first one was $100,000 plus. The second one was 20 after we worked out the problems. And we have more braiders than that now, but we still have the original two from 1979 that run every single day. I don't think they'll ever wear out.
Wow. We actually have a photo of wire or cable being braided, which is actually called winding. No, it's not that one. It's the one called winding. We're going to take a look at that picture that we just saw in a minute. There we go.
Yeah.
I mislabeled it. I called this winding, but it's really more properly called braiding.
Right. Because each all of one polarity, say the silver ones or white ones, are all rotating in one direction, and all the black ones are counter-rotating, and they interleave with each other. So it's truly a braided process. I think you can see it in the background a little bit as it's going around the pickup capstan there.
Mm-hmm. And that was your original idea, wasn't it, in that disco? Was counter-rotation, was taking the positive and the negative and
rotating them in opposite directions.
In opposite directions, which has a lot of canceling effect in the electromagnetic field that is generated.
Yes,
and that's the idea.
Yes, and of course the noise element in the original discos was very high because you had neon lamps, you had big strobe lights, and you had very crude switching gear to flash the lights, in some cases actual contactors, which of course had an arc when they disconnected.
Yeah, not to mention the disco ball, that had to have some pretty heavy lights on it that had undoubtedly introduced all kinds of noise.
Yep, and those lights actually had transformers driving power lamps, and so it was a highly inductive load. And so every time you switched one of those, of course, if you remove power from an inductive load, you have a backlash. And so it was a very hot noise environment.
Right. And so Kimber Cable, you founded that in 1970 something?
Yeah, we incorporated in 1979, but we had made our first cables back in 1976, 77.
Mm-hmm. And since then, you've obviously learned a lot, I'm sure, about cables. And I wanted to talk at some length about what are the factors in a cable that influence the sound or contribute to the sound of an audio system. Clearly, cables don't have sound themselves. They're just conveying electrons, current, voltage. But they connect components together. They can connect a source to a preamp, to a power amp, to speakers. And, there's a lot of discussion on many forums, including mine, AVS, about how cables contribute to the ultimate sound that you hear when you finally put your ears on it and listen. So tell us something about the different factors that are important and that you think about and incorporate in your cables.
Sure. Let's take speaker cables to start with, because that's where we started. In fact, it was maybe 10 years after we started doing speaker cables that we finally started manufacturing interconnects. With speaker cables, you're actually transferring current from the output of a power amplifier to a speaker. It's a very complex path because you have back EMF from the speaker that has to be damped. You have the output of an amplifier is typically the input to a negative feedback loop. and current limiting. And so there's a lot going on in that little teeny circuit there. And if the cable is reacting to it, you end up with trouble. Let's just take damping factor, for instance. But
which is a characteristic of a power amplifier.
Correct. It's a little simple division formula that involves the output impedance and the impedance of the amplifier, and you end up with a number. What people overlook is that the DC resistance of the speaker cable doesn't add to the impedance of the loudspeaker. It adds to the impedance, the output impedance of the amplifier. So a little bit of DCR could change the damping factor figure by a magnitude quickly.
DCR?
Yes. Damping factor really only operates at DCR because it's the ability of the amplifier to present essentially a short to stop the motion of the driver when...
okay, so DCR means DC resistance.
The DC resistance, yes.
Okay. As opposed to alternating current impedance, which is
correct.
The resistance to alternating current. Resistance is the resistance to
correct.
Direct current. Okay, I just want to make sure everybody understands.
And damping factor becomes more important the larger the woofer and the more with a suspension that is very springy. In other words, if the cone moves very easily, then damping factor would be more important than a smaller speaker where it has mechanical damping, where the cone shuts off.
Mm-hmm.
And just a little side note here. There's actually a rather simple way to tell if your speakers are going to really exploit biwiring. You can take a pair of speakers and hook them together, if you will. So no amplifier involved, but one speaker in the other room. Listen to the tweeter on one speaker and tap the woofer with a pencil eraser on the other one. And if you can hear it, in other words, if the tapping of the woofer is making sound go down the cable, through the crossover, and back into the tweeter on the other end, you probably should bi-wire it if the speakers are set up for it.
How interesting. Bi-wiring, by the way, just to make sure everybody understands that term, is when you take the output of an amplifier and you split it and you send one branch of that to the woofer and the other branch to the tweeter separately, basically bypassing the crossover in the speaker, right?
No, the crossover would still be there because you need to filter out low frequencies from the tweeter and vice versa. But
right.
But the way I explain it is that if you've got a large dog and a small dog and they normally behave okay but occasionally not, do you want them attached with one leash and them joined at the dogs, or do you want two leashes joined at your hand? And that gives you the additional control over the dogs.
Okay. All right. I gotcha. I was thinking of bi-amping, which you have a separate amplifier for each, the woofer and the tweeter. That bypasses the crossover. You really need a crossover outside to do that. But bi-wiring still uses the crossover. I gotcha.
Yeah, so you'd have an electronic crossover ahead of the amplifiers.
Right.
Okay.
Right. But in the case of bi-wiring, you don't. You use the crossover in the speaker to get rid of the lows for the tweeter because it can't reproduce them, and get rid of the highs before that get to the woofer because it can't reproduce those.
Yeah, well, the crossover still stays intact. It's just that the amplifier, the woofer tweeter, the woofer and the tweeter crossovers in the speaker, rather than being connected together on the back of the speaker, are now you've just extended double wiring back to the amplifier so they're connected at the amplifier.
Mm-hmm. And certain speakers offer this and others don't, so you have to keep that in mind.
Correct.
And so what you're saying is you connect the two speakers together with, so if the two speakers are bi-wireable, which means they have two inputs each.
Mm-hmm. Yeah, you would just run a single set of cables between the two speakers, put one speaker in one room and one speaker in the other room, so you isolate them acoustically, and then tap gently on just tap on the
Mhm.
woofer in one room and see if you can hear little ticks in the tweeter in the other room.
And if you can,
And if they're bi-wireable, you should do it.
Okay, good advice. Berniak in the chat room has a question. If braiding is a much better way to make a cable, why aren't all cables braided?
It's frightfully difficult to do.
Mm.
You can't do long production runs. You're limited to a few hundred feet maximum before you have to reload the bobbins. The stresses on the cable are higher. The machines run fairly slowly so that they don't nick the cable. It's really a bit of a thankless job to do it, and it doesn't lend itself to large production. We have a number of braiding machines, and so we can produce tens of thousands of feet a day, but that still isn't the 10,000 feet per hour that you could get out of a standard twinning, extruding production line.
Got it. Okay, so speaker cables are actually more complex than we might think, because it, of course,
Yes.
depends upon the interaction between the amplifier and the speaker and what their relative impedances are compared to each other, and that gets affected by the connection between them.
Yes. And then do you want me to go about interconnects?
Please.
All right. So on loudspeakers, if series induction is the largest contributor to lower fidelity, then parallel capacitance is that in the voltage domain of the interconnects. And and since we were all keyed in on noise in our early research, I considered the shielding of an interconnect, and of course thought it just simply had to be done.
Sure.
But we had listened to the prototypes pre and post shielding and were struck by the fact that the noise levels were virtually identical. We were braiding them again, a 3-wire braid, but it just sounded so much worse with the shielding on it. And so here's what I believe is going on here. If you have an interconnect and it's unshielded and you're picking up noise, you put a shield on it and the noise goes away. But that doesn't stop the internal cable from behaving like an antenna. You have geometry that behaves like an antenna, so you pick the noise up, and you have sufficient impedance along the length of its cable to develop the voltage. Of course, if it had zero impedance, you'd have 0 volts, so 0 noise.
Superconducting cables, that's the answer,
yeah,
right?
Well, or close to it. So consider this. Say you have a cable that is a twisted pair that's unshielded and it picks up noise. You put a shield on it and the noise goes away. You haven't changed the antenna effect or the impedance inside the cable. And since you could hear the noise, it means it's audible frequency. So now you've got the shield in place, you push play on the player, and now you've turned that little antenna, the twisted pair, into a transmitting antenna, and it will transmit part of your audio to the shield and dump it to ground. So you're stuck. You really can't have it behave like an antenna to begin with, or have impedance along its length, or whatever, or you're stuck. It has to not behave like that to begin with. Let me tell you a little story about. I'll even name names. This is Andrew Marshall of Audio Ideas Guide up in Canada. Okay. Amateur recording engineer of some skill, and he was highly curious about this, and he said, all right, I'll take that bet. I need 100-foot microphone cables. And so we sent him a 100-foot pair of KCAG completely unshielded. And he called me sometime later and said, unbelievable sound, really like them, but there is this tiny little, like a capacitive ticking charge that happens every so often, repetitively, that we can clearly hear at very low levels in your cables, and our normal microphone cables, Mogami or something, we just simply can't hear it. And I said, I have no idea. I just couldn't fathom what would be doing that.
So
And
it was like a clicking
like
sound
yes, yes. And
every
but the
once in a
answer,
while.
yeah, yeah, yeah. And he said it's highly repetitive. And so what happened was is that he called back a week later and said, we figured out what the noise was. And he said, in the back of the church is a clock. And with your cable, the noise floor was so much lower that we could hear the microphones picking up the acoustic ticking of the clock.
Oh, man.
And so he said, I am now convinced. And so he still has them and still uses them.
Now, these were unshielded microphone cables?
Completely unshielded. If you think of a pigtail braid like you do to your daughter's hair, just 3 wires just plaited together, that's all it is. But that's a very interesting geometry because the conductors don't lie parallel with each other, nor do they rotate around each other. If you were to pull one of them out, the other two would just simply fall apart. And it yields some very beneficial geometry when you're dealing with line level and microphone level.
Wow, because mic cables, you know, I've always believed that mic cables need to be balanced, and we haven't even talked about balanced versus unbalanced.
Oh, these would be balanced.
Oh, they're balanced. Okay, so
3 conductors.
What that means to those who might not know is that you're actually sending the signal from the microphone both in one phase and the opposite phase, and then that gets reversed at the receiving end, and any noise that gets picked up is then canceled out, essentially. I mean,
yeah,
that's a
common mode rejection.
Common mode rejection. It's a very, very simplistic, very quick explanation of what that is. But I've always believed that mic cables also needed shielding, but you're saying not necessarily so.
Not necessarily, and it depends on output impedance of the microphone and input impedance and circuit design of the mixer, and certainly shielding is a very big hammer against noise. So if you may end up with noise with our products or other unshielded products at some point, but if you can avoid bringing out the big hammer, you certainly should do that.
Okay, well, we got lots more to talk about, but before we do, I'd like to take a moment to thank one of our sponsors for this episode, which is Casper. Now, Casper is an online retailer of premium mattresses for a fraction of the cost. Casper's revolutionizing the mattress industry by cutting the cost of dealing with resellers and showrooms and passing the savings directly on to the consumer. Casper's mattress is obsessively engineered at a fair price. It uses 2 technologies, latex and memory foam, which come together for better nights and brighter days. It's a comfortable mattress that has just the right sink and bounce. A Casper mattress provides long-lasting comfort and support, and you can buy it easily online, completely risk-free. Casper understands the importance of trying out a mattress. Try sleeping on a Casper mattress today. They even offer free delivery and painless returns within a 100-day period, so you don't have to lie down in a showroom. I mean, I don't want to do that. And did you know, statistically, lying on a bed in a showroom has no correlation whatsoever to whether it's the right bed for you? So you want to keep that in mind. Even better, Casper mattresses are made in the USA. You can get a Casper mattress for $500 for a twin or $950 for a king-size bed. Holy smokes, compared to industry averages, that's an outstanding price. And believe me, I know, having bought a king-size bed myself quite some time ago, I wish I knew about Casper back then. And you can save an additional $50 as one of our audience members by going to casper.com/HTG and entering the promo code HTG. That's casper.com/HTG with promo code HTG. So, Ray, we've got a question in the chat room here from Superru, who asks, how important is it to keep the cable length the same for stereo speakers?
Somewhat, and it depends.
Never a simple answer.
Well, no, I think I can sum it up pretty well.
Okay.
Let's say that your system, and this includes the amplifier, speaker cable, and speakers, if they would sound quite a bit different at different lengths, then certainly you should have them equal length. There is at least a theoretical advantage to having them that way. If you've got a modest system, we say something like 1/3 to 2/3 difference. You're not going to hear it. It's not really measurable at that point at audio frequencies, and so we think that it's okay to have slightly different length cables. If you've got what I would term a fine hi-fi, and you've got good ears, and you really like finely detailing it, I think the reality of having the different lengths would probably play into your OCD enough that you wouldn't enjoy it. But more than that, we have done considerable research into absolute length of cables makes a difference. If, for instance, the cable isn't long enough to reach between the terminals of the amplifier and the loudspeakers, it doesn't work as good as if it's long enough to reach. And if they are considerably longer than that, it's highly beneficial to us.
Sure, because you sell cables.
Yeah, absolutely.
But I will tell you this. I once had a system in a studio that I was using to review products where I had cables that were a lot longer than they needed to be. And so I wound them up into coils in the corner. But I think that was a bad idea, wasn't it?
Yes. Now with the braided cables, you wouldn't actually make an inductor out of it because they're counter-rotating anyway. So
right. So it wouldn't really matter.
It wouldn't matter. But with a normal twisted pair or a quad or something that looks like a twin lead, just a pair of parallel conductors, you will literally make an additional passive crossover component between the amplifier and the speakers.
Yeah, that was a bad idea. I'm glad I'm not doing that anymore. Web 2519 is asking, where is Kimber Cable located?
We are in Ogden, Utah. That's about 30 miles north of Salt Lake City.
And you make all your cables there, right? So this is all made in the USA, yeah?
Virtually all. We have some parts that come from overseas. We use a lot of WBT connectors. We're the general agent for them in the U.S., and of course, those are made in Germany. And then some of the like the HDMI cables and things like that, we have a partner in China that makes those for us.
Mm-hmm. Mm-hmm. Creamy Corncob is asking, aside from cost, wouldn't fiber optic cables eliminate all the noise and impedance and other issues we've been talking about?
Of course, but you can't transmit power over fiber optic.
Oh, that's a good point. So you'll never have fiber optic speaker cables, is what you're saying.
No, because you'll still need an amplifier on the other end. But more than that, you'll also need an analog to digital converter on the source end, and then digital to analog converter to get it back into the power amplifiers on the other end. And having some experience with high resolution ADACs and DACs, I can tell you that gets very, very pricey to have ones that are sonically acceptable.
Mm-hmm. Yeah, I got you there. We were talking about braiding before, and I wanted to make sure we took a look at a couple of photos that you provided of these of cables that you've made for Sony headphones, and I imagine they would work for others as well.
Sure.
But let's take a look at those. Here's a close-up of that cable, and it's got kind of a unique feature. Why don't you tell us about it?
Yeah, well, if you've got a machine that's braiding, how on earth do you split it apart into two good braids at that point? And how
in the heck do you do that?
Well, I'm not prepared to tell you.
You could tell me, but then you'd have to kill me, right?
Yeah, probably. But this all started. Sony came to us, and there's a bit of a story with us and Sony. They had purchased our loudspeaker cables at retail from Denon, their competitor in Japan, when they developed the SSAR1 speakers. And
fabulous speakers, by the way.
Yeah, their electronics people had said that they felt that ours was the most viable electronically that they had ever found. So we really appreciated that. But then they wanted to do some headphone cables, and one of the problems was, how do you make that split? And so for the Sony, we have cables that we designed with Sony, and Sony manufactures, and those are available from Sony for their for their ZR7A, ZR7 headphones. But the split was always a problem because you either had to have a connection there, or a solder, or a crimp, or something like that. And so there is an intermediate connection on the Sony brand cables, but those are only $250. The ones on the picture, those will be closer to $1,000, and they will be there is a difference even holding them in your hand. You can tell the difference. And of course, we've got machined wood blocks. By the way, this is scrap hardwood that would have just been discarded anyway, so we're not cutting down any trees.
Good to hear.
And but the difference going between a standard cable and these is quite a big revelation. And those will be out. Those will be out pretty soon. As an added aside, we actually overcame the production problems faster than we anticipated, so we could produce before we had decided on pricing or a model number or a part number or anything like that. And so when we took them to the Newport show, we codenamed them Nemo, which in Latin means no name. And then I said, well, or we could just call them Horse with no name. And then when people were just being a little, that's Ray being goofy, I said, well, do you know why? And they said no, and I said, because America. And of course, America was the band that recorded A Horse with No Name.
Horse with No Name, right? Of course. Yes. Okay. Well, you're getting pretty esoteric there, but
I guess.
What the hell? Why not, huh?
So by Rocky Mountain Audio Fest, we will have packaging and production and part numbers and the whole thing. And but we've actually got stock now. We could ship them now.
And the really cool thing, as you say, is that you've developed some sort of braiding machine that allows you to braid both channels together, yes. And then at some point they simply separate out. Without any connectors at that point.
Correct.
Yeah. Speaking of connectors, obviously you need to have connectors at both ends, and the way in which those are connected to the cable is kind of important too, isn't it? We have a picture actually of someone performing some soldering, and I wanted to make sure that everybody knew that what you're doing at Kimber Cable is, I was just told by your colleague there that every cable that comes out of your factory has been hand soldered with the connectors at the ends. That's quite remarkable.
Right. There are some connectors where it's a pure crimp connector. But most of them are soldered. We about a year ago went to a nitrogen so it inserts a stream of nitrogen at the solder connection so that oxidation and other problems with the flux don't occur. There is a lot of research about soldering, and if it's done correctly, it is about as good as it gets. The cold crimping and the pressing and the ultrasonics and we even had for a while a Rofen laser soldering machine that we tinkered with for 4 or 5 years before finally deciding that what we were doing was sonically equivalent or superior at a lot less trouble. So we've sorted through that pretty well. The one thing talking about soldering is that if you do have a crimp connection, say you've got an amplifier that you're going to use you push the button and put the wire in the hole and release it, or if you put the wire loose in a terminal and tighten the banana plug down on it, do not tin it, because solder is only a fraction of the conductivity of silver or copper, and so you're just going backwards a little. I mean, you'll protect the wire from oxidation at that point, but inside the connection, it's going to be a gas tie connection anyway, and so you don't really gain anything. I'm going to invoke Doug Sachs a little bit here. Rest in peace, Doug. He had a saying that he said the best connector is no connector. And so if you can get away with doing a connector, so for instance, if you've got a receiver and it's got the little push to release terminals on it, just use bare wire.
Spring clips.
Yeah, spring. Just use bare wire, because if you use the little pins, then you've just got a knife edge contact, and so you've got less surface area, and you've got an intermediate connection for no reason. That's why we really appreciate the engineering with the WBT connectors, because they use a high copper content brass, so it's more conductive, and then they OFC copper plate it, and then electroless nickel, and then gold on top of that. So we use them when we do our recordings, we do the mastering, and when we do our demos. They're good.
Yeah. A couple other questions from the chat room. Neo asks, is there ever a scenario where braided cables shouldn't be used?
Maybe. Well, for instance, if you need a fireproof cable, for instance, if you're running it in a plenum airspace and you need loudspeaker cables and it needs to be CL2 rated, then because the production length of braided cables are so short, it would be stupidly expensive to try and put a flameproof jacket over the top of it. And so no on that. But if you're just doing, and there could be where you just don't need it. If you're running loudspeakers out to your garden and you're burying the cable, just use ordinary Malibu Lights 12 gauge carry wheel and bury it and get on with your life. Because, but if you care about what it sounds like, then I'm convinced that braided speaker cables really are superior to other geometries.
Certainly your outdoor speakers is not what we would call critical listening. So
correct.
Free Wi-Fi is asking, does braiding or shielding have any effect on digital audio interconnects like SPDIF or USB?
Yes. Well, now you're off into a completely different discussion, because you're just doing essentially little square waves for digital. You're not using analog, so it's not changing frequency. So yes, you can certainly shield those, and we do on ours. But we also use, for instance, AES EBU. We have a version of that that's completely unshielded. That's the right impedance, and it works great. So the shielding, non-shielding issue doesn't play as much into the overall design of the cables. You just have to make sure that you don't have too much parallel capacitance in those little digital cables, because you'll round the corners off, and eventually you'll screw up the timing of the signal a little bit, especially at high bit rates.
Round off the cables of the corners of the square waves.
Square waves.
That's what
yes.
you're talking about. Yeah.
Yes.
Yeah. You mentioned earlier about copper, silver, gold, and so what is your feeling? I mean, there's so much stuff around about the material that cables, wires, conductors are made of. You know, OFC copper. I think you mentioned that, oxygen-free copper. There are super long crystal copper. Right. Silver and so on, gold plating. What is your feeling generally about the materials that are important? What's important about the materials in cables, in conductors?
Well, there's really only two metals that are reasonable for audio: silver and copper. And in general, the finer the grain structure or the longer the crystal, the better. The higher the purity rate, the better. The slower that it's drawn and processed from draw stroke into strand, the better. If you can extrude it in an oxygen-free environment. In other words, if you flood the extrusion head with nitrogen stream, that means you're not capturing air and moisture underneath the jacket, which will turn copper to green mush eventually sometimes. And silver has a slight advantage in absolute conductivity, but more than that, if you're doing pure silver, you can get the surface finish finer than you can on copper simply because of the melting point of the metal. I'll digress for just a second here and say that I am not a fan of silver-plated copper, and here's the reason. Right after it's manufactured, silver-plated copper is pretty darn magnificent, but it starts going downhill right from there because the layer between the silver and the copper sets up a little oxide layer, like a little crummy diode array, and so it eventually sounds tizzy and shrill and funny, but at the get-go, it would sound pretty darn good. But
not for long.
So we only use pure silvers or pure coppers.
I guess some people who would use silver-plated copper, that is a layer of silver over a core of copper, might invoke what's called the skin effect, in which it's claimed that most of the current or the electrons travel on the surface, on the skin of the conductor, not throughout the entire cross-section. Yeah. Do you believe that?
Well, of course, skin effect is well known, and it's true. It happens.
It's a real thing. Yeah,
it's a real thing. And a lot of people say, well, it doesn't matter at audio frequencies. That's true if you are simply talking about sine waves. But actual music has transients which have rise times and fall rates that correspond to much higher frequencies if you were to just simply to form the waveform after that. And so you have instantaneous signal that will travel on the skin, I believe. We think that we're confident that you don't want to have a surface that has surface contaminations in it from the drawing process. You don't want to capture contaminants under the jacket, which will cause the surface of the conductor to oxidize in the jacket at some point. And so I believe that if you can get the cable to reliably pass high frequency and do it for the reasonable life of a cable, say 30, 40 years or more, then I think you're better off. But that's just me.
Well, and you got some serious study and knowledge to back it up. So I do appreciate that very much. Before we continue, though, I would like to thank our second sponsor for this episode, believe it or not, which is Epson. Now, I'm a big, longtime fan of Epson projectors. And here, though, and I've also been a longtime fan of Epson printers, have one sitting in my office as we speak. And what we're talking about here is the new Epson Workforce printers powered by Precision Core. Workforce is an award-winning line of printers, of all-in-one printers for your home office, small to large business, or corporate work groups. Precision Core provides performance beyond laser and is the new printing technology that powers the Workforce printers. This technology was initially developed for industrial printers and is now available for the rest of us. Workforce printers deliver fast, dependable, high-performance, multifunction, and workgroup printing to help businesses run at full speed. You get print shop quality output with vibrant colors and clear, crisp text. The cost per page is half that of a color laser printer. As a worldwide leader in innovative business solutions, Epson understands your needs. That's why their technologies are designed to help you succeed solving tomorrow's business problems today. To help keep your business moving forward, they focus on enhancing output and efficiency for a better bottom line. Their products are backed by world-class service and support. They have innovative technologies that cut costs without compromising quality, and their products are recyclable and energy efficient. There are several reasons to choose Workforce with Precision Core over a laser printer. Unlike laser printers, there's no warm-up time. You can print on a wide range of media, including labels, And they're far more energy efficient, up to 70% less power than laser printers. Epson, built to perform. Go to Epson.com today and find out what the workforce powered by Precision Core printers can do for your business. That's EPSON.com. Very easy to remember, highly recommended. And as I said, Epson, built to perform. Okay, we're talking with Ray Kimber about cables, and we've gotten pretty geeky here, but hey, this is Home Theater Geeks, so totally cool with me. Let's spend a couple minutes talking about the debate, which has been raging for decades, about how much influence cables really have on the sound of an audio system. We've learned now that braiding can make a big difference in terms of noise cancellation, noise reduction, shall I say, and other things, good connections, soldering, and so on. But can it? As I'm sure you know, there's so many people debating about, yes, they make a huge difference. No, they don't make much difference at all. There's this whole issue of can we ABX test cables to sort of scientifically determine how much difference there is? What is your sense of this whole debate?
Theoretically, I think that ABX is a great idea, except that the use of the ABX hardware gives you a lowest common denominator, and I'm just suspicious that it won't provide all the fidelity that you need to make good choices about that.
Interesting. So in other words, the ABX hardware, the box in the middle that switches between one and the other, is where you're going to get quite a bit of degradation, and maybe any differences that might exist are going to be equalized in a sense.
Yeah, or just below a certain threshold. And that's not to say that ABX isn't highly useful for some things, and they do as good a job as they can. But the fact of the matter is, it's still additional stages of electronics and the switching circuits and so on. But I can tell you how we demoed cable for new dealers back when we first started, and I would go into a dealer who would maybe never heard of us and say, here's what I'd like to do. I'd like you to take the smallest two-way speaker that you sell the most of. So something that was their bread and butter. And then I said, and now I want a receiver that is the cheapest receiver that you sell the most of that has a speaker A, speaker B switch. And so we would hook up one speaker cable on one and one speaker cable on the other, and set the speakers next to each other, and so that we're dealing with the same channel. So right channel is switched between the other right channel, and the difference was pretty darn convincing. We had so close to 100% close rate with an order before I walked out the door that it wasn't funny, and so that was simple. It was understandable. It was straightforward, and it could be repeated any number of times. My one experience with a giant ABX demo was at AES in New York, maybe 15 or 20 years ago. I don't know. And someone who was really having a problem with so-called perceived sound rather than measured sound, and cables were one of those. And they had really done a kind of a questionable demo. They had mid-level teal speakers on platforms in front of a room of a few hundred people, so they were above head level, so the whole energy was firing into the ceiling, and a modest high-quality amplifier. So they were using really good gear, but this should have been for a demo in front of a half a dozen people at the most in an appropriate sized acoustic space. And so the demo went on for a while, and then the guy got up there and he was quite he was quite a showman. And at one point he he said and waved his hand out to the audience and said, "So how many people in this audience have some of those so-called golden ears?" And he said it with a very derisive tone of voice. More than 3/4 of the audience raised their hands. and that pretty much shut the demo down right there. He was he just slunk off the stage essentially.
Wow.
And we never heard another word about it.
Huh. Well, so much for that. Creamy Corncob is asking a similar question here. What are your thoughts about overpriced cables? I mean, you know, your cables, I'm sure, aren't cheap because you spend a lot of time and you have a lot of machinery and so on. But I mean, they can get astronomical, these cables. I mean,
yes, and so do ours. What you're buying at the high end is you're buying absolute diminishing returns. There's no question about that. Or you're borrowing bragging rights, and you're buying trophy construction and trophy materials that don't directly lend itself to any audio performance. We of course have cables in our line that are best buys. For example, they're little hot rods. The VS series is one that comes to mind. But we have a policy that dealers can send back cables at any time. We'll just simply take them back. So you could go to one of our dealers and at least on our end of it, because we'll take the cables back, you can make arrangements with the dealer and they should take them back if you want to demo them. I know that a number of dealers do that. And a few years ago, we had somebody who wanted to try an all-silver system. This was tens of thousands of dollars worth of cables on a relatively modest system. So it could be that the cables equal the cost of all the hardware. Wow. And they, and the dealer said, the customer just straight up is curious, wants to try it. Are you game? And I said, absolutely, we'll send them to you. So we sent them down, and after a week or two, the dealer said, okay, we got them back from the customer, and we're sending them back to you. And I said, fine. Before we got the cables back in UPS, the dealer called back and said, turn them back around. The customer is going to buy them.
Really? Wow.
Yes.
Wow. And so he felt that he was getting enough benefit to justify spending as much on his cables as on the entire rest of the system.
Yes, that's true. And
more or less.
And
yeah.
Yes, cables can trick you up in very interesting ways. Like I say, even if you spend just a few dollars a foot for speaker cables from us, even if you've got speakers and amplifiers where you've spent, I don't know, a couple of $1,000 or under $1,000 if you were buying good stuff off eBay, you would hear an advantage that wouldn't be minor. It would be obvious.
I got a question here. Ripple Rider in the chat room is asking, if cables affect the sound quality noticeably, as you've been saying, then how does the internal wiring of speakers with thin gauge wire and push-on pad connectors, how does that affect the sound? I mean, you're not in the speaker business, but maybe you've looked inside some speakers and seen what kind of cables they're using in there?
I can tell you that a number of speaker manufacturers use cables from us OEM, and in some cases we're not allowed to say. For instance, Tannoy on their higher-end speakers used Kimber Cable exclusively for years. They may still do it and getting that from our UK distributor, but it does, and those cables do make a difference, but they are proportionally much shorter, and they may be post crossover components, which would make less of a difference. But certainly, if you improve the wiring either inside the amplifier or inside the speakers, you're going to get a difference. But proportionally, because the length between the cabinets and the amplifier are much longer, there's an advantage there. Why make it any worse than it has to be, I guess?
Well, in our last few minutes, I'd like to turn away from cables and to another project that I know is near and dear to your heart. which has to do with recording, and specifically using a really cool microphone, or a microphone array, I guess, called isomike. And we have a couple pictures of that too I'd love to show people. And while we're taking a look at those, you can tell us how you're involved with this. What are you doing?
Well, it's my invention, essentially. I'm convinced that if you don't have enough adult supervision and you're in high-end audio long enough, you will want to make your own recordings, build your own speakers, and build a pipe organ. And I'm pretty much all there.
Wow, you built a pipe organ, in fact?
Well, I'll send you some pictures. It's
okay.
a rather ambitious organ project that we're donating to the local university. But it's not the microphones per se, but the baffle that isolates them from the acoustics of each other. So isomike. Okay. And oh gosh, kind of a long story about how if you're picking up two microphones and they're hanging apart, you'll end up with essentially a fixed flanging effect based on it. And
I mean, that's normally how stereo recordings are made. You have a pair of microphones that are hanging there. Either their capsules are close to coincident, or they're some distance apart, or whatever.
Right. But if you get them close to each other, then the way that you get the right-left separation is because the microphones are cardioid. In my mind, that gives you other problems. And so you can see the microphone cables hanging down on those arms. So the microphones are standard omnidirectional microphones. But this means that acoustic information that bounces off one auditorium wall is associated with the microphone closest to that wall. It doesn't just jump through to the other microphone and interfere with its original signal. And so each microphone sees that. And so you are accomplishing separation with precedence of arrival and not with power apportionment. And that's how we hear, is by precedence of arrival and not by power apportionment.
So just to make sure everybody understands, precedence of arrival is which ear does the sound arrive at first, right?
Correct. Yes.
And so if the sound is coming from your right, it will arrive at your right ear first and then diffract around your head and end up in your left ear some milliseconds later.
Microseconds, but
microseconds later, actually. Yes, thank you. And so that's very, very large part of what gives us our ability to localize, to find, to detect and know where the source of that sound is.
Absolutely right. And it turns out we did some basic experimentation to determine if there was some kind of an optimal spacing for microphones to be reproduced back in speakers. And we decided that if you disregarded every other aspect, that 5-6 feet was probably really good. Now, that isn't to say that there aren't other microphone array. There's Schneider disc, there's Jecklin disc, there's the XY
binaural
arrays. Well, binaural back to headphones, that works very, very well.
As long as you're listening back in headphones.
Right, and it's not a bad, and it's not a horrible experience listening to it with speakers. My underlying thought about recording is that recorded music is like canned sushi. You can't do it, but there's a big difference between albacore and pet food.
Okay, I'll grant you that.
Yeah, so we're fighting a losing battle, essentially, trying to do recorded music, but we're working closer and closer to a goal that at the end is not quite attainable in an absolute sense, because a live music in a real hall will always have a different essence to it than reproduced music.
Even, and I agree with you, don't get me wrong, I totally agree with you, and I've run polls on AVS to this effect. Can reproduced music ever sound indistinguishable from live? I believe that it cannot. But what if you were to have a surround system, or even an immersive sound system with speakers around you this way and speakers above your head this way? That gets a little closer, maybe?
Yes, it gets you much closer. And I can use the analogy of CGI. you can get astonishing realism from CGI video output, but at some point there will always be that little something that says, not real.
Especially, I've thought about this a lot myself, and I've realized that that is especially true of human faces. So, which is why when you go to an animated movie, you could have photorealistic grass and trees and houses and all that stuff, but the human faces all look obviously animated. They don't. There have been some attempts to make it real, but to make it look real, but you get into this thing called what's it called? The Valley of Creepiness. It's not what it's called, but it's called something where you get close enough and it starts creeping people out.
The Uncanny Valley.
The Uncanny Valley. Thank you very much, Josh.
Oh, yeah, I new one on me. I'd never heard that. But
yeah,
so we're back to canning sushi, and but it's a good thing, because sometimes there are performances where the artist has passed away, or you can't travel, or you can't go to that optimal hall, or you want the convenience of having a reasonable replication for your enjoyment in your own home. And so recorded music is absolutely fantastic. And I just wanted to fail in a new way when I started out with the isomike project. And I think if you Googled isomike, I think you'd find some very favorable comments about what we were able to succeed with.
Now, have you released any recordings that were done with the isomike?
Oh yes, there's quite a number of commercial releases that have been done, and I might make mention that Kimber Cable pays for all of the production, the replication, the licensing, everything to do with the discs, the recording expenses. And then if we sell a disc for $20, we give the school $20.
Nice. Speaking of school, I want to show that picture one more time of the band on the football field that was being recorded by an isomike. I myself am an old marching band guy. I was, a drum major in high school, and I played trombone and tuba and marching band. I love marching bands. And so here we have this wonderful marching band on a football field being recorded with an isomike.
Yes.
It must sound phenomenal.
Well, let me. This is actually a drum corps. These
drum
are the
corps. Okay, all
right. These are the Blue Knights.
Oh, great drum corps
from Denver, and they were leery a number of years ago, and all it took was one little demo, and they were in. So we've recorded them every year, weather permitting, ever since. And so it's a completely acoustic performance. We're about 30 feet off the field and 30 or 40 feet back. So the horn lines are literally way back from that, and it lends an absolutely stunning recording. In order to get the noise floor down, we are able to have the school turn off all of the air conditioning on campus, because the main chilling plant is next to the stadium. So 25,000 student population gets warm in the afternoon. We reroute. We talk to the tower at Ogden Airport, and they reroute general aviation away from the campus.
Wow.
And the police block off the nearby streets, so there's no traffic noise.
That's incredible, because of course there's no walls. I mean, unlike what we were talking about before in a concert hall, where you've got reflections off the walls and so on. Here, it's outdoors. It's essentially infinite. There are no walls, so there's.
Yeah, you get reflections off the press box and off the opposite stands, but it's a pretty darn glorious recording, and so it's called high altitude drums, or attitude drums, as the case may be for those guys. But the signal to noise ratio is 60-70 dB. And the dynamic range is in excess of 60 dB. So when you hear those tiny little hand-struck chimes down almost to the noise floor, and then it just comes at you at full force, that's all natural, because there's no processing, no mixing, no nothing. It's absolutely pure.
So that's straight to 2-track, no compression, no EQ, nothing like that.
actually straight to 4-track because it's a 4-channel configuration. But yeah, and we record in DSD, and now we're recording in quad DSD, so the 4X DSD.
Man.
Yeah,
well,
I'm convinced.
Well, this is fascinating, and there's probably a lot more to talk about, certainly in terms of DSD and 4 times DSD. So I would love to have you back sometime if you'll agree to come back and join us again.
I have had a good experience, and it's also my first experience at Skype. So thank you for dragging me kicking and screaming into new technology.
Into the 21st century. Well, it's my pleasure, and thank you so much for being willing to get dragged screaming and kicking. Not so screaming and kicking, though. You've done a great job, and I really appreciate your time. Thank you so much.
Thank you.
That's Ray Kimber of Kimber Cable. Their email or their web address, of course, is Kimber, KIMBER.com. You can find me always at avsforum.com. You can email me at scott@twit.tv, and you can follow me on Twitter at htgeekscott and also at avsforum. You can always find previous episodes of Home Theater Geeks right here at twit.tv/htg. and on our YouTube channel, youtube.com/twit Home Theater Geeks. Next week, my guest geek is scheduled to be David McKenzie, a top-flight calibrator, TV calibrator, but whose day job is as a compressionist and colorist for Blu-ray discs. So we're going to be talking about that next week, and it should be great, interesting discussion, and I do hope you will join us. Until then, geek out.